This lesson, we're going to be looking at more of what we can do with Node, some history of Node, also how Node relates to the browser, the window object, the document object, and the global object in Node and how it works. So let's go back to the documentation where we left off last, and that's the Node website documentation. So console is one of the ones that we're going to be using quite often, and mainly we're going to be using the console log in order to log content out into the console, but there's a few other options here as well. So you can look through the documentation, select the method that you're using, and you get these code examples. So you can either copy and paste the code into your editor and run the Node file to get a good sense feeling for what's going to be output. In addition, there's also some information about the different parameters that you can use and what's being expected, so whether it's a Boolean or a string, and what happens if there's a callback on this. And we are going to be covering the relevant methods of Node in the upcoming lessons. So a lot of these, once you go through the lessons, are going to become a lot more familiar to you. Errors, how to handle the different errors with the error classes. You can generate page content. You can create, open, and write files, delete files on the server or on your local machine. And Node just has the regular JS file extension. So it's not actually a programming language, it's a runtime environment because it interprets the JavaScript code using the V8 engine. This is how Node works behind the scenes, and this is why we're able to run JavaScript. And the same thing, same idea as we have within the browser, where Chrome has the V8 engine in the background. It takes in the JavaScript code, it interprets it within the V8 engine, and then it returns back the results. So Chrome also sends C++ bindings and allows the browser to interact with the DOM. So if you are familiar with JavaScript and interacting with all of the page elements within the web page, this is the same idea, that we're interacting with all of the different methods that are available within Node, and all of this done using JavaScript and going through the V8 engine. So Chrome methods in JavaScript are sent through the V8 and it runs C++ and returns the functionality. Node sends the JavaScript to the V8 engine. So it takes the JavaScript code that you've written within your JavaScript file, it runs it and sends it over through the V8 engine. The V8 engine again interprets the code and returns back the results to the application, and that allows it to render out those results. And a quick brief history of where it got started. So in 2009, Node.js was created using a C++ running the same V8 engine as within the browsers. Prior to 2009, JavaScript was only available within the browser. And also in 2009, Node Package Manager was also released. And we're going to be talking a whole lot more about Node Package Manager in the upcoming lessons. And the V8 was originally released within Chrome in 2008. So just 1 year ahead that Chrome was released within the browser, and then Node came along using the same backend engine. When we open up the console in the browser, we can type in window. It's going to return back the window object. So this is all of the stuff that's available within the window, and this is a series of all the different methods that we have access to. We can also type in document, and so document is actually part of the window object, and this as well is an instance of the current visual document that's being output on the page. And we can select these, we can manipulate these. So if we open it up on Visual Studio Code there, go into the console, and if I do document, body, and if I do something like inner HTML, and if I set it to hello world, it's going to remove out the rest of the HTML content and only have hello world written in there. So we're still on that same website, and when we refresh it, everything comes back. So for those of you that are familiar with front-end coding with JavaScript, you would be familiar with the document object because that's how you're interacting with the contents of the browser, and that's all contained within the document object. So let's clear the terminal, as well as you can press the clear console, and that will clear out any content that you have in here. And then within the console, you can just write any JavaScript. So you could do 4 + 4, and it will return back the results. And as well, there is the window object. So the window object is different than the document object because this is the entire window. So the whole browser window is what's referred to as the window object. If you do type in window within the console of your browser, you're going to get returned back the window object. And as you can see, it actually does contain the document object within it. And it contains a bunch of methods and properties for all that you can do within the browser window. So if you go down to the document and you open up the document, this is going to be referencing that same document object. So the document is contained within the window, and that's how we interact with the browser content using JavaScript. And as well, you could just type in the document, and that will return back the document object. And if you do want to be able to list it out as we were listing out the window object, you could do a console and directory and document, and this will list out the document object, and then you can look through the object contents and select items and properties from the object and update them just as we did with the inner HTML. So now let's open up our editor and we'll take a look at the Node file that we were running, the app.js, and let's open up the terminal. So do a new terminal there. And I'll get rid of the HTML file. And we'll run the node app1.js. So if I do a console log in, if I type something like the window object, and if I run the same application, I'm going to get an error that the window is not defined, and that's going to be the same thing for the document. So I have no window, I have no document within Node, but we do have a variable called global, which acts in a similar format, and this is a node global object, and this allows us access to various methods that are available within Node. So within the global object, we've got the clear interval, clear timeout, set interval, set timeout. So it acts similar to what we saw with the window, and it returns back access to this global object that we're going to be going into more detail as we go through the upcoming lessons. One of the benefits of Node is that it's non-blocking asynchronous, which is also what makes Node highly scalable and fast because of the non-blocking asynchronous nature of it. It does not need to wait for a response before moving on to the next request. It's a single thread. It handles all of the requests, so it can go from one request and send it over and waiting for the response. But while it's waiting, it can get the second request and then the third request as well while it's waiting, and it's going to be all set within queue. And the responses, whenever it gets returned, it's also going to be able to execute that code. Essentially not having to wait for the response, and it can move to the next request. And that's what we mean by non-blocking asynchronous. So blocking or synchronous. So that means that we have to wait. So the single thread will have to wait to get a response before it moves on to the next request. And so there is a big speed difference when you look at the two different models. Whereas this model, when we get the first request, we've got the single thread, it goes to the response, it has to wait till we do get the response, and then it moves on to the second request and waits for the response, and then finally it moves on to the third request. So there is a big difference in time. So the time that the processor is going to need to handle the request is not going to change. So it's always 10 seconds in our example here. So it doesn't matter how many requests we make, they're all going to take 10 seconds. But what does make its difference is how we can process them and if they can run at the same time. Let's say we have 10 seconds to do the response. When we make the request, we wait 10 seconds for the response. We make another request, we wait 10 seconds for the response. Another request and 10 seconds for the response. So that means that altogether it's going to be over 30 seconds. Whereas whenever we're doing it asynchronously, we can do the request. We still are waiting for the response, but in the meantime, we're making another request and we're still waiting for the next response, another request, waiting for the next response. But then when the responses come in, they're going to be one after the other, and the time difference is going to be quite a bit substantial to what we had to do when we had the sequential type format where we had to wait for the requests to get finished and processed. So for CPU intensive applications, when your CPU is making the requests and it's going to use up a lot of the CPU power, then it's better to give it, space it out. But whereas if we're using up little CPU power, we're not using it all up, then we can handle multiple requests at the same time. So the main advantage really is in speed, is that the requests can be made while we're waiting for the response back from the previous request. So the asynchronous non-blocking part is one of the main reasons why everyone enjoys working with Node. So let's get coding some Node in the upcoming lesson.